Hey everyone, and welcome today. We are talking about one of the most powerful and, let's be honest, coolest things on the entire planet, volcanoes. We're gonna dive deep, and I mean literally deep, into the Earth to figure out all their secrets. Ready? Let's go. I mean, you've seen the videos, right? A mountain just explodes. Have you ever just stopped and wondered, why do they do that? What is going on inside our planet that causes something so massive? It's a huge question, and we are going to find the answer. But that leads to an even bigger question, doesn't it? Could one of these incredible things erupt somewhere near you? That's a pretty serious thought. Understanding the why is the first step to figuring out the where. So, let's get started. To get our answers, we can't just stay up here on the surface. Nope. We have to take a journey way down, deep beneath our feet, because that's where the story of every single volcano begins. Because here's the thing, volcanoes have all sorts of personalities. Some go kaboom in these massive explosions. Others just kind of ooze with lava flowing out. Some bubble away, and some, get this, can even build brand new islands right out of the ocean. How cool is that? All right, it's time. Put on your imaginary hard hats, because we are going on a journey to the center of the Earth. We're going to see exactly where all this power comes from. So our planet is basically made of layers, kind of like a giant onion. On the outside, we've got the crust. That's the ground we walk on. Then you get to the mantle, which is this super hot, goopy middle layer. And right in the middle, you've got the core, the fiery, hot center of the whole planet. Okay, so looking at those three layers, which one do you think is the home of all that hot melted rock that fuels volcanoes? Go ahead, shout it out. If you said the mantle, you are absolutely right. Gold star for you. And this super hot melted rock has a name. It's called magma. Magma is the main character in our story today. It's the key ingredient just waiting and building up pressure deep underground. Now, really quick, let's clear something up. What's the difference between magma and lava? It's so simple. It's all about location. When it's underground, we call it magma. The second it erupts and comes out onto the surface, boom, we call it lava. Same stuff, just a different address. Okay, so we've got all this magma hanging out in the mantle. But how does it get all the way up here? Well, you can think of the Earth as the ultimate pressure cooker. It's all about heat and gas building up until something has to give. You know what it's really like? It's like shaking up a bottle of soda. All those fizzy gases get trapped, and they push and build up so much pressure. It's the exact same thing with magma. Gases get mixed in, the pressure builds and eventually, kaboom, it has to find a way out. So where does it escape? Well, the Earth's crust, the part we live on, isn't one solid piece. It's actually broken up into these giant puzzle pieces called tectonic plates. And these pieces are always slowly moving around, crashing into each other, pulling apart, and it's in those cracks where the plates meet that the magma can finally burst through. Now let's talk about the different styles of eruption. Like I said, they're not all the same. You've got your gentle ones that just kind of ooze, and then you've got your really big boomers. So on one hand, you've got the explosive kind. These are the ones that make a huge boom and shoot ash and lava miles up into the sky. Total showstoppers. Then you have the gentle kind, where the lava just flows out quietly, making these incredible glowing orange rivers of rock. Okay, be honest. Which one do you think is cooler? The big, dramatic explosion or the slow, mesmerizing river of lava? What do you think? Shout it out. Both are pretty awesome, right? And you know what? The way they erupt actually creates their shape. The gentle oozers form these wide shield volcanoes. The really explosive ones build up tall, pointy, composite volcanoes. And then you have these little cinder cones, which are small but can be super fiery. All right, let's bring this science into the real world. We're going to meet some of the most famous volcanoes on Earth. And then we're going to talk about the most important thing of all, how to stay safe. Time for a quick world tour. In Japan, you've got Mount Fuji. It's that perfectly shaped, iconic mountain. In Hawaii, there's Mauna Loa, the biggest active volcano in the world. It's so heavy, it's actually squishing the ground beneath it. Then there's Mount St. Helens in the US, which had a huge eruption back in 1980. Krakatoa in Indonesia made one of the loudest sounds ever recorded in history. And Soufriere Hills reminds us that some volcanoes are still erupting today. Okay, this part is serious. Volcanoes are incredible to study, but they are also incredibly powerful and dangerous. So there are 3 simple rules you always have to follow. Number 1, stay far away. Number 2, listen to the scientists and the experts. And number 3, if you see a warning sign, respect it. It's that simple, and it could save your life. So, quick pop quiz. If you ever saw lava in real life, do you go get a closer look for your social media, or do you get farther away as fast as you can? Yeah, that's an easy one. You get far, far away. So let's wrap it all up. Here's the whole story in just 4 steps. First, deep inside the Earth, heat melts rock into magma. Second, gases build up pressure inside that magma. Third, the magma pushes its way up through cracks in the Earth's crust. And finally, boom, a volcano erupts. And now, a challenge for you. Think about it. If you could design your own volcano, what would it be like? Would it be a gentle giant with slow rivers of lava? Or would it be an explosive fireworks show that shoots ash high into the sky? Think about all the amazing science we talked about today and decide. Thanks for joining me on this incredible journey.